Hi everyone, I'm Zhonghua Yu from Yuzhongwan TV on YouTube channel. Today I'm gonna talk about the Berquist Sherman model. Actually, it's not a model. It's just as the original paper says, it's like adequacy of case outstanding, but they did apply some of the like regressional analysis and regression model to come up with their own way how to restate the historical case outstanding triangle or paid loss triangle. And actually, like the first one and second one is just directly, we directly got it from the original paper written by Berquist Sherman. But Friedland, actually, she's the one who, found this new model, and probably she thought it is very, convenient for any actuary to do their job as a, consultant. She is a consultant at KPMG in Toronto. I don't know, maybe she moved, like elsewhere, but when I was working there, over there in Toronto, she was there still at the KPMG as a actuarial consulting leader. And today I'm gonna, show exactly the same model, but slightly different against her own data. Okay, here. Uh, when you read the, reserving book, the estimating unpaid claim estimate based on like basic technique, that book, she like, maybe, I don't know, she just, like get this data for like not the real company XYZ insurer, and auto BI means automobile bodily injury. So usually it has a long tail to settle down, and the amount itself is a lot bigger than the other one. And here, she just applied the Berkshire Sherman like adjustment methodology on this, the pseudo company data. And when you look at it, it's like it starts with the average paid claims. When it says that, it's just divide the paid loss development triangle by closed claim count. It doesn't matter whether they are cumulative or incremental. Let's get along the way. It's just, we just can get average paid loss per each claim. And the reason why she star this is that probably the like Berkshire Sherman did, the case outstanding, like like fluctuation is like too big. So maybe she tried to get an estimate of trend factor from the paid loss development instead of case outstanding. So when we try to, let's say, estimate the trend factor, we have to always work with the average, right? The one unit, okay? So exposure unit or one claim unit. So that's why we get the average paid claims, which quite often we say severity, but it's not a ultimate severity. It's like, immature severity as well. And here, upon this one, we try to get the exponential regression here. I'm just trying to get the, like the increasing ratio here, growth function, to do the, to calculate the, like increasing ratio. When you apply the exponential, as I already mentioned, and all in this case, by all different accident year, the increased ratio is all the same. So I took only one of it to come up with the, increasing ratio. And I have done it. Actually, she has done it all different development period, and it gets, like number of like data gets smaller here. So probably you can make a, like selection based on this region. And first year is 8.1, and second development year 5.4, and so on. And this is, R square, and probably you doubt, like, R square is much smaller than we expected. So yeah, I can say 46.3% is very poor fit. So what I would do in our practice, maybe I'll try to find some more information regarding this one. But what is it? Like, when it occurs and how much paid out in first year, right? That's what it says. I mean, all the accident probably year is going to be distributed from January 1st and December 31st. And then some of them probably, like there is a transaction to pay the requested amount. And when you draw this into a graph, something like this, right? And like 8 years ago, it was much lower, but it jumps up and then stays there, and there is a, small like a down here, but it seems to be like for the last 4 or 5 years, it is like, tends to be increasing. And I would probably find out like, let's say a couple of years ago or 3 years ago, is there any like, some additional environmental change? And even 7 years ago, what was happening here, right? This year, based on this data is correct. Reconciliation done, and I don't have any suspicion about the data quality. Based on the assumption, data is correct. And then I can do some of the, let's say, initial analysis to see this trend look okay, something like that, especially for the, like earlier development period. So maybe I can introduce like dummy variable, or I can introduce additional independent variable other than just accident years, right? And to like, get more improved results. Anyway, this is just, for the illustration, and this data is not the real data. Anyway, like, out of, let's say, this one, even though here data is small, I just simply take the average, and that is 5.3%. And the, the author selected 5% from the average paid claims. You remember the original Berquist Sherman paper, they came up with a trend factor based on average case outstanding regression, right? So this is your own actuarial judgment. So, well, like which data do I have to use? It all depends on your, actuarial judgment. You just, show it objectively, all the, like a backup data like this, and then you have to explain it in the disclosure. So once I select 5%, and I can use the trending against the, like the case outstanding. Okay. So it's like, like previous, just average case outstanding trending factor, I apply it, and then I got it, and I apply it to the case outstanding. But here, trend factor is estimated from the average paid loss development triangle, and I come up with the 5%, and then use that 5% to apply the case outstanding, especially average case outstanding to the trended. So most current one, let's say, year 2015, this just stays there because, it's like best, like probably data that I can predict the future with. So use 5% of selected and I detrended to restate the previous average case outstanding. From there, I can create case adjusted reported claims again, right? Like the original paper. So here, this one is like average one. So I have to multiply the open claim counts and then plus the paid loss amount. And I get case adjusted reported claims. And after I adjust the reported claim, and then I apply the loss development method. And you can get, like much more stable link ratio. And based on that, here it selects that volume weighted average. But this year, she just take the latest 3 years one, 3 years one, right? And then in terms of accident year, probably, this 3 years. Yeah, she thinks, like the most recent 3 years compared with the, let's say, the, like last 7 year to like, let's say 4 year, this seems to be like too high. And there might be some reason why this, like between first year and second year development is much higher than the most recent time. That's why I indicate, I might introduce even in the regression to come up with a trend factor as a dummy variable, right? There might probably something happen over there. Anyway, most recent 3 years, and the case outstanding restatement is done. And using, let's say, the ultimate claim count, development, the estimate, and also I got the disposal rate, right? You just like divide closed claim count by this ultimate claim count, and you can have a disposal rate. And this is like all development all the way up to 1, right? And using this, after I select the disposal rate for each like different development period, I got it. But here, as a, let's say, this is like just a like convenience purpose because it is just illustration. She just took the latest diagonal as a, like representing disposal rate. And then I apply the disposal rate against the ultimate claim count, and I restate the previous closed claim count. So this is like, new independent variable in the regression, right? That's why she applied the same stuff. And then also for the, accident year, like this, original, this is like not the adjusted one. And this just, okay, I use formula, something like that. And this is probably, yeah, this is closed claim count for XYZ insurer. And that one by, like accident year 2005, 6, 7, and you can verify that based on the exponential regression analysis, you can see the very, very close direct relationship between the paid loss amount and closed claim count. Now you are very confident to work with that. Okay, and again, we use, this is unadjusted closed claim count. That would be the independent variable in our regression upon the total triangle framework. And the paid loss amount is the one that we try to adjust it and predict it, right? So this is a response variable, and we have a 2-point regression. But when we do the 2-point regression to come up with the adjusted paid loss amount, and we use the adjusted closed claim count using disposal rate, right? And that's another estimation. That's going to be the new independent variable. So here I can show you the formula again, like I did last time. And here, this 2 is an independent variable in the exponential regression, right? And this one is a response variable in this exponential regression. And when we try to come up with the restated or adjusted, paid claims, we use adjusted closed claim count as a new independent variable. And I have this one, right? And if I move it left side or right side, this time right side, something like this, right? It keeps moving. And this one, this. So 2-point regression. And this one, how am I going to do that? Here, I already told you in the previous video, this is like a so-called, I would say, extrapolation, right? And here is the same story. Oh, I'll just delete it here and see again. Oh, sorry. Latest one is I just, took it from the one before. Oh, sorry. Oh, here. I got the wrong one. Yeah, this one is like what? Latest diagonal is just based on the unadjusted paid loss amount. It's the same. So we don't need, do the regression here. Anyway, it's like, same like triangle base regression. We got new adjusted paid claims amount. And so based on that, we apply the loss development method and come up with much more comfortably the selected link ratio. And based on that, and we come up with a different one. And right now, we we did the first part, historical case outstanding restatement, adjustment, and secondly, the paid loss, historical paid loss, adjustment, restatement, and then we can combine those two, right? Here is an open claim count. Open claim count, we don't do anything. But here, she didn't do anything, but we can do something, right? Because, like based on the uh, let's say reported claim count or closed claim count, we can come up with the ultimate claim count, and we like apply the disposal rate to come up with the new adjusted closed claim count, or maybe we should subtract the adjusted closed claim count from the ultimate claim counts, and we are going to get adjusted open claim count. But here we just use the unadjusted open claim count. And we have the adjusted case outstanding, right? Triangle. So we simply divide it, right? And we get adjusted. I'm sorry. Oh, it did. Oh, I'm sorry, I got confused. This one is adjusted open claim count. So when you have a look at it, and here, this is adjusted closed claim count. And this is the one, probably the original. There, reported claim count, right? So reported claim count just stays the same. We just restate, adjust the closed claim count. So instead of original closed claim count, we subtract adjusted closed claim count from reported claim count, which is not changed. We would get the new adjusted open claim count. Sorry about that, your confusion. Anyway, we get the new adjusted open claim count, and then when we have, let's say, both adjusted, meaning that we adjust case outstanding and paid loss amount, the same thing, right? And when I look at the formula here, and this adjusted open claim count times adjusted average, sorry, this one and adjusted average case outstanding, right? So both one is adjusted. Adjusted open claim count times adjusted average case outstanding, and that's when you got adjusted case outstanding, and plus adjusted paid claims, right? So that's what we did. We adjust both case outstanding and paid loss amount. So that's why it is called both adjusted reported claims. And here we apply the loss development method to come up with the, like loss one. This one is select the same thing, the last three, the reason three, but volume weighted average, right? You just use the reported loss amount as a weighting, not just most recent 3 year simple average. It's like volume weighted average. And if I get it, based on that, there is a LDF and also reported portion, the proportion. And here is a summary of what she has done for the XYZ insurer. And this is the given data, right? Unadjusted. And this is just summary of cumulative development factor to ultimate. What about you can think of it as uh, this one is adjusted reported, right? And I adjust only case outstanding. And this one is both. And this is alone paid loss adjusted, right? You have to like distinguish. And this one is just like summary of three different columns. It shows the cumulative development factor, and this is based on that LDFs, and we come up with the ultimate reported loss or ultimate paid loss based on each like development factor. And here we go. So those are pretty like looks very similar, and we can summarize it something like this. So we have the project ultimate based on each and like different adjustment, and you have the unpaid, meaning that the case outstanding here, and then those are IBNR based on different adjustment. So those are the summary. And this one is like all the comparison, but you realize that here when you do apply the regression on a triangle base based on the like closed claim count and original Berquist Sherman paper, when you have done it, just here Berquist Sherman applied the linear regression or exponential regression to come up with the future LDFs, right? So that's what I tried to do it here. And you just based on this dependent variable, response variable, and this independent variable, and next one, right? This is like on a calendar year base, year 2016. So the age to age factor for between 48 and 60th, so 4 year and 5 year development, what the age to age factor is gonna be, right? Based on exponential. The Berquist Sherman did like, both, right? Linear regression and exponential regression, and come up with the this one and compare the like three different LDFs. But here she just thought it's her actuarial judgment. I don't want to apply the regression to predict the future age factor. I'll just select based on this. So it's partly like she made a decision that not to do another selection here, like unlike what the Berkshire Shaman did. So, like when you look at this type of heavy adjustment, even sometimes you make the decision or perform your own actuarial judgment whether to select like certain type of like adjustment or not. It all depends on you. Just I want you to be exposed to whatever methodology out there, even though it was like, like more than like what already like close to 50 years ago, right? It's a long time, but they're like those kind of like very practical or very pragmatic, like practice example exists there. And then when you try to come up with the like assumption or a parameter to for you to be able to like create the future cash flow scenario much better. And you have to remember always out there historically in an advanced country a lot of smart actuaries develop something, and that's going to be very available, and that is still very helpful for us to be able to do something, right? And that's how you can improve your actuarial technical skill, or you can upgrade your existing model to project the future cash flow. Yeah, like those three videos is for the Berkshire Shaman. Don't look at it as one of the technique that we can just come up with the, let's say, the IBNR estimation, or like estimate the future, the reported loss or paid loss. I just point out that those adjustments could be done because historical data is sometimes might be very dirty, or what you mean. What I mean is that there are a lot of, let's say, like informations that you have to consider. So as I already mentioned, there could be a different underwriting, let's say, strategy. So there might be in some, specific times there might be like a much worse, contract than the other, or you get a new claim manager and claim process is, totally like changed, and also like regulator put some like a regulatory restriction on it, and that's going to change our historical triangle, or some of the macroeconomic environment changes, and that's going to affect our like historical data. At least 10 years you have to disclose in the IFRS 17 financial statement. So when you say 10-year is not short period, right? There's going to be a lot of changes. So the basic idea for Berkshire methodology is that how can I like restate the historical case outstanding or paid loss so that I can based on purely current situation. I already mentioned about the COVID-19, right? COVID-19 affects our probably like medical reimbursement, medical indemnity, coverage, or automobile. Probably there's gonna be a lot, like let's say lower frequency and lower severity, and people don't drive that much during the period. So when you have the data, let's say up to now, by the end of let's say 20 2022, you have a 10-year historical data, even though you can display it quarterly or annually, semi-annually or whatever, and you can see like a whole lot different, like trend there. Like I showed you in the Freeland example for the XYZ insurer, she just took the most recent 3 years, the link ratio as a selection. So I already pointed out that like for the most recent 3 or 4 years, and then the other rest of the year during the whole 10 years, there might be something happen there. And in the future, in Korea or elsewhere, in Europe or even the States, because it's like a global pandemic, right? So when you look at the data, you have to always remind yourself of the fact that COVID-19 does have a huge impact on our data itself. So you should not just be based on most recent 3 years, because it's, even though it's a 3 year, it's a very short-term phenomenon. And in the future, it's not going to be like that, right? I don't say we are gonna like get back right away immediately before COVID-19, but even after COVID-19 period, it's not as severe, or it's not as very positive in terms of our claims profile. It was not like that. So when you have the data and try to like draw some of the assumption or parameters, you have to look at like before COVID-19 as well. So how can you make sure that, after COVID-19, and sometimes you have to make the decision, okay, I'm gonna just delete the most 3 year data, or how I can, like maybe do some of the like adjustment based on it. It's going to be very tricky, and it's going to be very hard. It's going to be very, I would say, creative. So it needs your like creative capability to work around it. Just average it and apply it, or most of 3 years is very very positive. So that's why you're gonna have, a lot higher or bigger CSM or expected profit or something like that, right? Even in the actuarial assumption or parameterization. So you have to remind yourself always of this fact. And please do remember, this is not just a, simple mathematical manipulation. It's actuarial science. You have to be scientific to work scientifically, especially to project the future cash flow. It might not be accurate, or it might not be very credible, but that's our job, right? So before I show you how I can, like demonstrate, so whatever company I can do the validation of your IFRS 17 like measurement results. I can do audit. And if you want to be able to do that, you have to know some of the fundamentals, even though I call it actuarial like paradigm shift, but it's still there in the framework of actuarial science stuff, especially for at a very practical level. And that's what we would be able to do it. So I mean, probably, next time I'm gonna talk about probably the loss ratio, because people are probably like rely on loss ratio too much, and I try to point out that, and before I to introduce all the actuarial working model to estimate the future, like distribution of all the different cash flows and how we can aggregate together to do the onerous test and then perform the subsequent measurement later on. Thank you very much and see you later. Okay, bye.